Think math.
Apply the test to 3/6. Factor the 6 and you get 2 times 3. There is a 3, which is neither a 2 nor a 5, so it ought to repeat. But divide it out and you get 0.5, which stops dead. Is the test wrong? Look again at what the test was really examining. Whether the denominator can be turned into a power of 10. But the denominator there means the one that survives to the end and actually holds the value. In 3/6, that 3 was destined to disappear along with the numerator. Testing a doomed factor was the mistake. A denominator's prime factors come in 2 kinds. Those that pair off with the numerator and cancel away, and those with no partner that survive to the end. Only the survivors decide how the decimal ends because a canceled factor leaves no trace in the value. So, reduce first and look only at what is left. It matters that reducing does not change the verdict. 3/6 and 1/2 are the same value. Same value, same decimal, and therefore the same ending. Reducing is not an operation that alters the answer. It reveals the real denominator that was hidden. The 6 was a costume worn over the top. Check whether the trap runs the other way too. Could reducing conjure up a 3 that was not there? No. Reducing only removes factors, never creates them. So the misreading happens in one direction only. Something that looked like it repeats turning out to terminate. That is exactly why we reduce before testing. So the denominator the test looks at is the denominator of the reduced fraction. Factors that are about to cancel have no bearing on the ending, so clear them away first. That closes the terminating test. Next time we start turning repeating decimals back into fractions. See you in the next one. A sip of math every day here at Think Math.